You build memory systems flat, narrow, stuck in text. They fumble context, drowns in raw data, forget the user's rhythm. You train on single-modal chats. They hit walls when screens flash, images speak, life gets visual. Ever feel like this is your life with AI? Okay, let's unpack that little research rant. We often talk about AI learning, but let's be honest, most systems have been pretty forgetful, like comically bad sometimes. They've got these basic memory setups that just don't cut it. They get lost in the conversation, can't handle pictures or screenshots well.
Right.
Today, we're diving deep into a fascinating new development that might just fix this massive headache. We're talking about getting these digital brains to actually remember.
And it's funny, from a researcher's point of view, we build these incredibly complex language models.
Yeah.
But then we often forget the basics. We assume they know things, but honestly, beyond the immediate prompt you just gave it, most AI is basically stateless, like Dory from Finding Nemo, but less charming. So our mission today, really, is to look at how some really smart people are trying to fix that. We're aiming for AI that doesn't just respond, but actually learns and grows with you persistently.
Okay, let's really dig into that problem first, because I think everyone listening has felt this pain. You explain something super clearly to your AI assistant, and literally 5 minutes later, it's asking you the same question again. It's maddening. That's that flat, narrow, stuck-in text thing we mentioned.
Precisely. It's stateless beyond the current chat window. It doesn't carry context forward effectively. That's why you might feel like you're having the same introductory conversation over and over again.
Exactly. And it's not just about forgetting text. It gets even worse when you try to bring in other stuff.
Absolutely. The multimodal challenge.
Yeah, like showing it a picture or a screenshot of that spreadsheet you were just talking about. The AI might be a whiz with words, but suddenly it's like, computer says no.
It hits a wall.
Yeah.
Because it wasn't really built for that rich, visual, mixed type of information.
So for you, the user, what does this mean? Well, it means you're repeating yourself constantly. The AI never really learns your preferences or work habits, and you just get this feeling it doesn't know you.
And this brings up a really fundamental question for us in the field. What does it actually mean for an AI, like a large language model, to truly remember?
Right. It can't just be like a giant hard drive.
Exactly. It's way more than just storing data. It's about keeping that data long-term, being able to reason over it, find the right piece of information quickly and accurately, and doing all that at scale, especially with messy real-world stuff like images and complex interactions, not just neat little text snippets. Current systems, they often struggle because their memory isn't organized intelligently.
Okay, so that paints a clear picture of the problem. Now, the exciting part, what's the solution? You mentioned this new system, MIRIX.
Yes, MIRX. And it takes a totally different approach. Instead of one big, messy memory drawer, think of it like building a specialized memory ecosystem.
An ecosystem, I like that, like different parts working together.
Precisely. The core idea, riffing off that intro bit, you design MIRX with 6 minds, not one.
6 distinct memory types. Okay, that sounds organized.
It is. It's not just throwing more storage at the problem. It's about structured, specialized storage. Each mind or memory type has a very specific job.
All right, break it down for us. What are these 6 minds?
Okay, first up, core memory. Think of this as the AI's bedrock. Its unchanging identity, your fundamental preferences.
So this is how it finally remembers my name is David, not user123.
Exactly. Or that you always prefer summaries bulleted. High priority, persistent facts. It's always there, always visible to the AI. Huge for consistency.
Okay, core memory. Got it. What's next?
Episodic memory. This is like the AI's personal diary or calendar. It logs time-stamped events and interactions.
Ah, so it remembers when we talked about something.
Yep. Like 2025 Zoo3 05 10:104 a.m. User discussed project proposal with John. It builds a timeline of your interactions, which is crucial for understanding context over days, weeks, months.
Makes sense. Core for the constants, episodic for the timeline. What about general knowledge, like facts about the world?
That's semantic memory. This holds abstract knowledge, concepts, entities, relationships. Paris is the capital of France, or photosynthesis converts light into energy.
So it's like the AI's own internal Wikipedia, but when it can update.
Sort of, yeah. It helps the AI understand the broader context of your requests and relate them to general world knowledge.
Okay, 3 down. What about actually doing things, like remembering steps?
Good question. That's procedural memory. This is all about structured processes, workflows, how-to guides.
Ah, like remembering the steps for, I don't know, booking travel through the company portal.
Exactly. Or a multi-step recipe, or a coding workflow. It stores actionable step-by-step knowledge. It knows how.
Number 5.
Resource memory. This one's for the specific files and documents you're actively working with. That picnic plan you mentioned, or project brief, a meeting transcript.
So if I upload a document, it keeps track of it there. I don't have to keep refeeding it the same file.
Right. It maintains continuity for ongoing tasks that involve specific resources. Very practical.
And the last one, you mentioned a vault.
Yes, the knowledge vault. This is super important. It's a highly secure place for sensitive verbatim info. Think passwords, API keys, your home address.
Okay, security is key there.
Absolutely. It uses strong access controls. This info isn't just floating around, it's locked down and only retrieved when explicitly needed for a specific secure task. Builds trust.
Wow, okay. 6 specialized minds. That's definitely more sophisticated than a flat file.
Yeah.
But how do they all work together without becoming a tangled mess?
Great question. That's where the meta manager comes in. Think of it like an orchestra conductor.
Conducting the memories.
Exactly. It analyzes what's coming in your request, screen activity, whatever, and routes the information to the right specialized memory manager. There's one manager for each of the 6 types.
And they work in parallel.
Yep, humming in parallel, as the intro put it. They update their own memory stores efficiently without stepping on each other's toes. No redundancy, less chaos.
And there was something else. Active retrieval. No more search memory prompts.
Ah, yes. This is a huge leap for usability. Active retrieval.
So what does that mean practically?
It means the AI gets smarter about anticipating what information it needs. You don't have to constantly tell it, hey, search your memory for that thing we talked about last Tuesday.
It just figures it out.
It infers the likely topic based on the current context, proactively digs into the relevant memory stores, maybe Episodic for the timelines, Semantic for a related fact, and pulls what it needs to answer you properly. It feeds the language model the right context automatically.
That sounds seamless, like how human memory sort of works. You don't consciously search most of the time. Stuff just comes to you.
That's the goal, making the interaction fluid, making the AI feel like it's actually keeping up with you, using its memory intelligently, without you having to micromanage it.
Okay, the structure sounds brilliant. Active retrieval sounds like magic.
Ah.
But does it actually work? How did MIRX hold up when they tested it? Because theory is one thing, right?
Right. And the testing is where this gets really impressive. They don't just use toy problems. They threw some seriously tough, real-world benchmarks at it.
Like what?
First, ScreenshotVQA. This benchmark is, well, it's brutal.
Brutal how?
Imagine sifting through nearly 20,000 high-resolution screenshots taken from a PhD student's computer over weeks. It's messy, it's real activity, full of context shifts, asking questions about that visual history. That's hard.
Wow, yeah, I can see why most AI would just melt down. Storing all those images alone sounds like a nightmare.
Exactly, that's the point. Traditional methods struggle. A standard approach, like our using a visual model, only got about 44% accuracy and needed, get this, 15 gigabytes of storage on average.
15 gigs. Just for one user's history.
Yep. And even powerful long context models like Gemini, they choked. They had to shrink the images way down and still only managed about 12% accuracy, using over 200 megabytes.
Ouch. Okay, so how did MIRX do? The suspense is killing me.
MIRX achieved 59.5% correct. That's a 35% jump over that RAG baseline, and a massive 410% improvement over Gemini in this test.
Okay, significantly better accuracy. What about the storage? Was it also huge?
This is the kicker. MIRX used only 16 megabytes total storage on average.
16 megabytes, down from 15 gigabytes.
Exactly. That's 99.9% leaner. It's incredibly efficient because it doesn't store raw pixels. It intelligently extracts relevant information and stores it structurally. It understands the visual data without drowning in it.
That is genuinely astounding. Okay, so it nails messy visual data. What about conversations? Long ones, where facts get buried.
Right. That's the other major test, LOCOMO. This stands for long conversation memory. Think long chat histories, average 26,000 words, where recalling specific details or connecting facts mentioned hours apart is key.
The kind of chats where you definitely forget what was said at the beginning.
Precisely. The big challenge here is multi-hop reasoning, connecting different pieces of information that aren't stated together, like figuring out where Caroline moved from when her hometown was mentioned way earlier.
Yeah, that requires real understanding, not just keyword matching. How did MIRX do?
It hit 85.4% overall accuracy, which is about 8% better than the previous best methods. But the really impressive part was in that multi-hop reasoning.
Let me guess, it nailed it.
Pretty much. 83.7% accuracy on multi-hop questions. The reason is how it stores information. Remember, episodic and semantic memory.
Yeah.
Instead of just storing raw chat logs and making the AI try to piece things together later, MIRX creates consolidated events. So if the chat mentions Caroline moved 4 years ago and later her hometown is in Sweden, MIRX might store a single combined fact. Caroline moved from hometown Sweden 4 years ago.
Ah, so it connects the dots as it stores the memory.
Exactly. It consolidates the information intelligently. So when that multi-hop question comes along, the answer is right there, readily available. It doesn't have to desperately stitch fragments or cobble bits together from the raw text like other systems. Much faster, much more reliable.
Okay, this is really convincing. It's not just theoretical. It's showing massive gains on tough, realistic tasks, both visual and conversational. And it's incredibly efficient. It backs up that intro claim, right? It's not just storage tricks.
Definitely not. It's about intelligent organization, specialized processing, and this active retrieval mechanism working together.
So this is amazing research, but how does this actually get into our hands? What does this mean for you listening right now? Is this just lab stuff, or is it closer than we think?
Well, excitingly, it's not just a paper. The researchers have actually built an application based on MIRX that you could potentially use.
Oh, really? Like a desktop app?
Yeah, something that runs on your computer, monitors your screen activity with your permission, of course, and starts building that personalized memory base automatically.
So it watches what I do, understands the context visually.
Exactly. It captures screenshots, smartly filters out duplicates or minor changes, and updates the relevant memory stores. Episodic for what you did when, resource for files you opened, semantic for concepts you engaged with.
It offers visualization too, so I can see what it remembers.
And critically, they emphasize secure local storage. Privacy first. Your memory stays on your machine unless you choose otherwise.
That's huge. So you can literally watch it, learn your projects, your documents, your typical workflows without sending everything to the cloud.
That's the idea. Handling images, text files, almost like second nature. Getting rid of those stateless assistants, finally stopping the endless. Remind me again what we were talking about.
Okay, that application sounds incredibly useful already. But thinking bigger picture, if this tech works so well on a desktop, it seems perfect for, well, things we might start wearing soon.
You read my mind. Wearable AI is a massive potential application. Think AI-powered glasses like Meta's Ray-Bans or X-Real Air, or those AI pins like the Humane A pin or the Rabbit R1.
Right. Those devices see and hear what we do, but they're typically pretty limited in storage and processing power.
Exactly. They often lack persistent long-term memory. MIRX, with its efficiency and structured approach, could be a game changer there. It could build memory in real time from audio and visual streams.
Remembering conversations, recognizing faces or objects based on past encounters.
Learning your habits on the go, recalling details from something you saw hours or days ago, and its modular design fits well with the hybrid on-device cloud models these wearables often need. Imagine your glasses reminding you of someone's name and the last thing you discussed with them, just as you meet them.
That's powerful stuff, but you mentioned the vision goes even further, something about a marketplace.
Ah, yes, the agent memory marketplace. This is the really ambitious, maybe even slightly sci-fi long-term vision from the researchers.
Okay, intrigued. Memory marketplace.
The core idea is pretty profound. What if your AI-curated memory, your experiences, your learned skills could become a new kind of digital asset?
Whoa. My memories as an asset. How on earth would that work? And wouldn't that be a privacy nightmare?
They propose a layered structure to handle that. Layer 1 is the AI agent's infrastructure, the foundation of personal AIs, wearables, etc. Layer 2 is absolutely critical, the privacy-preserving memory infrastructure.
Okay, privacy first. How?
End-to-end encryption for everything. Fine-grained user controls you decide exactly what, if anything, gets shared and with whom. Potentially even decentralized storage, making it harder to censor or control centrally.
Right, user control is paramount, so assuming that privacy layer is rock solid.
Yeah.
What's the third layer? The marketplace itself.
The memory marketplace. A peer-to-peer ecosystem where users could potentially exchange or even trade tokenized memories.
Tokenized memories, like what?
Think practical things, maybe highly effective productivity workflows someone has perfected, specific niche expertise, maybe even curated life advice based on documented experiences.
So I could, like, buy a memory package on how to expertly use Photoshop from a pro user.
Potentially, yes.
Right.
Or contribute to expert communities building a shared verifiable knowledge base. They even float more out there ideas like AI clones for fan interactions.
AI clones, based on someone's memory.
Yeah, imagine interacting with an AI persona of an influencer or expert that's enriched by their actual documented experiences and knowledge. Or even using memory profiles to accelerate dating or professional matching. It definitely pushes boundaries.
Pushes boundaries is an understatement. That's a lot to think about.
Yeah.
But it all comes back to that core innovation, as the rap said. You didn't build a better memory bank. You built a memory ecosystem where AI doesn't just store the past. It understands it for good, for real, for everyone.
It really shifts the paradigm, which leads to, I think, a really important question for all of us to consider.
Go on.
If AI can truly, deeply remember your life, your experiences, your habits, your knowledge, what incredible new possibilities does that unlock for truly personalized assistance, for creativity, for human AI collaboration? But also, what new responsibilities does that place squarely on our shoulders? How do we manage this incredibly valuable, incredibly personal digital asset? How do we define the boundaries of what an AI should know, remember, and potentially even share about us?
Definitely something to mull over. What does it mean when our digital companions might remember our lives better than we do? We'll leave you with that thought until our next deep dive.
欢迎收听豆包 AI 播客节目。
Hello， 大家好，欢迎收听今天的播客。然后咱们今天来聊一聊啊，就如何通过 MIRIX 这种多代理的记忆系统啊，来帮助这个基于大语言模型的这种 AI 啊，获得更加丰富的记忆能力。
听起来非常有趣，那我们就直接开始吧，来看看这个 MIRIX 到底是怎么回事。
对，那我们今天就是要聊一聊这个 MIRIX 到底是个什么东西啊，它能做什么，有什么样的优势。
MIRIX 它其实是一个模块化的多代理的记忆系统。它是为了增强这个 AI 代理人的这种记忆能力而设计的。那目前呢，很多
欢迎收听豆包 AI 播客。
记忆能力
听起来非常有趣，那我们就直接开始吧，来看看这个 MIRIX 到底是怎么回事。
对，那我们今天就是要聊一聊这个 MIRIX 到底是个什么东西啊，它能做什么，有什么样的优势。
MIRIX 它其实是一个模块化的多代理的记忆系统。它是为了增强这个 AI 代理人的这种记忆能力而设计的。那目前的很多的这种记忆方案呢，它其实都是比较平面的、单一的。那 MIRIX 它不光是可以处理文字，它也可以处理视觉的和多模态的信息，所以它可以支持这种更加复杂的真实场景的应用。
听起来确实很厉害啊。那它的核心的特点有哪些呢？
它有6种不同类型的记忆模块。然后它还有一个多代理的框架来控制这个记忆的更新和提取。它的这个实验的结果也是非常惊艳的，比如说在这个 ScreenshotVQA 和这个 LOCOMO 这2个数据上面，它都大幅的超过了现有的一些方法，甚至它可以做到就是减少很多的这个存储的需求啊，同时可以提升这个准确率。
MIRIX 它是在一个什么样的背景下产生的呢？或者说它是为了解决什么样的问题而设计的呢？
就是随着这个大语言模型的发展，那现在的这种基于大语言模型的这种 AI 代理人，它在执行一些复杂任务上面已经表现得非常优异了。但是呢，他们的记忆能力其实是非常欠缺的，他们很难去立住一些用户特定的信息，然后在对话的过程当中呢，也很容易陷入一些重复，或者说没有办法很好的去适应用户的需求。那 MIRIX 就是为了解决这些问题而设计的。
听起来确实是一个很关键的问题啊。那它具体是怎么解决这些问题的呢？
它是通过一个非常精心设计的架构，它有6个记忆组件，然后有8个智能代理，来处理这些不同类型的数据的存储和提取。同时呢，它还有一个非常创新的叫做主动检索的机制。所以它可以非常精准的找到这个模型回答问题所需要的信息。同时呢，它的这个实验的结果也是非常惊艳的，比如说它在这个信息提取和这个长对话的处理上面都远远超过了现有的一些方法。
MIRIX 它都有哪些具体的应用场景，或者说它未来可能会在哪些领域发挥作用呢？
它有一个非常直观的应用，就是它有一个跨平台的应用程序，然后你可以用它来监控你的屏幕，它会自动的帮你建立起一个 个性化的记忆库，你可以通过这个记忆库来进行一些可视化的操作，或者是进行一些安全的本地的存储。
听起来非常实用啊！那它还可以用在比如说像穿戴设备上吗？
完全可以啊，就是它非常适合这种智能眼镜或者是这种 AI 的 pin 这种形式的，因为它可以处理这种音频的和视觉的这种数据流，然后实时的帮你形成记忆。同时呢，它的这个模块化的设计也非常适合这种硬件资源比较有限的这种设备。同时，它也支持这种本地和云端的这种混合的管理，所以它可以非常好的去适配这种穿戴式的 AI 代理人的一些需求。
MIRIX 它的这个记忆系统是由哪些部分组成的呢？或者说它是怎么来管理这些不同类型的信息的呢？
它是一个模块化的架构，它有6个不同的记忆组件，比如说核心记忆，它就是用来存储一些高优先级的信息，然后这个情景记忆它就是用来存储一些跟时间相关的用户的活动，还有语义记忆是用来存储一些抽象的知识，还有过程记忆是用来存储一些操作的流程，资源记忆是用来存储一些文件类的资源，还有一个知识宝库是用来存储一些敏感的信息。每个组件其实都有自己非常明确的分工，
听起来非常细致啊。那它这个信息的提取是怎么做到高效准确的呢？
它有一个非常创新的叫做主动检索的机制，就它会主动的去帮你生成一些话题，然后根据这些话题去找到最相关的信息，作为这个模型的一个系统提示的输入。
对，
所以它可以非常精准的找到这个模型回答问题所需要的信息，而不是像传统的方法那样可能需要更多的人工的干预，或者是说会有一些过时的信息被错误的使用。
今天咱们聊了这个 MIRIX 它是如何通过这种模块化的多代理的记忆系统来让基于大语言模型的这种 AI 代理人获得更加丰富的记忆能力啊，无论是从它的这个应用场景还是从它的这个实验的结果来看啊，都展示了非常大的潜力。
OK 了，以上就是这期播客的全部内容了，然后咱们下期再见吧，拜拜。
拜拜。